Welcome to AP Daily Topic 7.5, Magnitude of the Equilibrium Constant. This video will help us understand the relationship between K values and their corresponding amounts of products and reactants when the reaction has reached equilibrium. I am Sam Wires, an AP Chemistry student at Bayport High School in Green Bay, Wisconsin. So first, what is K? K is a value used during equilibrium of a reversible reaction to represent the ratio between products and reactants. For example, you can see that Kc is written as the concentration of products over the concentration of reactants. Then we will take a look at this simple reaction right here. And we can see that we take our products, the C here, and we put those in the top of our equation, and we take our A and our B and put them in the bottom. Now we take the mole amounts of each of these products and reactants and we put them in the power spot in the K equation. And this is what gives us a correct K value. How does K change? We know that products are over reactants. So when we add or subtract products or do the same with reactants, K will change. If we have 1,000 product molecules over 10 reactant molecules, we will get a K value of 100, which is a relatively large K value. But if we were to flip the amount of products and reactant molecules, then our K value will flip to 0.01, which is a relatively small K value. What we can also use K with is the pressures. And all that would change is we take the concentration of our products and reactants and change them to the partial pressures of each product in each reactant. If we use the analogy of the poppy experiment that we did in class, if our reactants are the individual beads and the products are the linked together beads, when equilibrium is reached, we will have a lot of reactants and not a lot of products. This happens because it was much harder to put them together than to take apart. Because of a skew towards the reactants, our K equation will be like our one before that gave us a small K value, not many products and lots of reactants. Now, if we were to flip the reaction and say that we started with many of the long chains and we took them apart, we would flip our K value. Now when the equation reaches equilibrium, there will be a large number on the top for our products and a small number on the bottom for reactants. Our K value would then be greater. Now, in this instance, with our large K, we would end up with lots of reactants. This would mean that our equation goes almost to completion. Now, in the previous slide, this one here, we, with our reactants as the individual beads, we would have less products and more reactants. This would mean that our equation almost doesn't proceed at all. Now we are going to look at a multiple choice practice problem. The equation says at night an equilibrium reaction between two different nitrogen compounds generates N2O5 in the atmosphere as represented below. And it asks a mixture of NO3 and a tenfold excess of NO2 are placed inside a rigid container at constant temperature and allowed to reach equilibrium. Which of the following provides a correct comparison of the equilibrium concentration of these chemical species and why? So let's start by looking at our K value. Now our K value is 2.6 times 10 to the negative 11. So that is a very small K value. And like we saw before, there will be many more reactants than products to get our small K value. So when we look at A and B, we see that they favor the consumption of reactants. And with our small k value, we know that we have plenty of reactants. So we know right away that both of these are wrong. Next, we'll go to C and D. And we already know that we're going to have more products than reactants. So we just match these up to our products and reactants from our original equation. And we see that D is the correct answer. Lastly is a summary of what we learned. K is a value that represents the ratio between reactants and products in an equation. A small k value means that there are more reactants than products at equilibrium, and a large k value means that there are more products than reactants at equilibrium. Thanks for watching, and I hope you enjoyed.